I wanted to introduce our two presenters today. First of all, Lou Feinstein is a product manager for Solidworks Electrical, infusing electrical DNA into Solidworks, as he says. He's a former engineering manager who's worked in a variety of industries, including communications, data storage, and aerospace and defense. He holds several patents for electrical and electrical-mechanical design, assembly, and fabrication. And Joe Wilkie is going to start us off. He is the product sales manager for Solidworks Electrical in North America. He holds a degree in electrical engineering as well and has worked for Solidworks since 2004. So with that, Joe, I will hand it over to you.
Okay, thanks, Cliff. So thanks to everyone for joining us for this webinar today. Today what we'd like to do is take a high-level look at SolidWorks Electrical, and then we'll turn our focus to accomplishing cabinet layout and design using two different methods. First, we'll look at the process of creating a 2D cabinet layout using the integrated tools inside the SolidWorks Electrical Schematics tool. And then we'll cover the steps and some of the advantages of using SolidWorks Electrical 3D for this task for those users who are using SolidWorks for their mechanical design as well. Now, before we start talking about electrical cabinet layout specifically, I'd like to share with you what we've observed over the last couple of years working with hundreds of SolidWorks Electrical users around the world. What we've seen is that prior to using SolidWorks Electrical, with companies, regardless of their size or the products they design, they generally follow a three-step design process. First of all, they need to draw their systems to establish the logical definition. And that means they're selecting parts from online or printed catalogs. They're drawing any special cables that they may require for fabrication, and that basically creates the logical definition of the project. Next, they're able to move on to a documentation stage where they have to document their system in a way that's useful to different audiences. For example, a designer might scan through all of the drawings to construct a bill of materials or document each wire connection that they find in the schematics to make a comprehensive from-to wiring list. This task typically results in many manually created and manually managed spreadsheets by the time it's all done. Now finally, since these spreadsheets are in no way linked to the original CAD files, all the documents must be regularly audited. And the problem with ensuring these documents are accurate, it becomes exponentially more complex as more designers collaborate on the project. And of course the challenge with this, since it's entirely manual, is every time we make a design in the product development, we have to go back to the beginning and repeat these three steps over and over again. So really the purpose of SolidWorks Electrical is twofold. First of all, with our powerful schematic creation tools, SolidWorks Electrical helps designers work more efficiently than they can in general purpose CAD systems. And SolidWorks Electrical also features a lot of time-saving tools that help designers get their job done faster. We'll talk about those as the presentation goes on. And the second purpose of SolidWorks Electrical is really to provide powerful project management tools to keep track of all the project details and updates. So any change made in one area of the project will be reflected in all of the relevant areas. So effectively what we're doing is we're fully automating the time-consuming and error-prone process of creating, updating, and checking many separate engineering documents. So the collaborative engine behind SolidWorks Electrical offers tremendous value to project teams. With SolidWorks Electrical, all of the project electrical and mechanical designers not only share symbol and component libraries, but they also are able to work simultaneously on the same projects. The SolidWorks Electrical Project Server keeps everyone up to date with the latest changes in real time, and this is all done with no manual intervention or manual manipulation of any data files from the users. This is what makes SolidWorks Electrical truly the first system to offer a practical approach to electromechanical design collaboration. Now, for the designers, we provide many time-saving automated features, such as intelligent design schematic creation tools, automatic customizable wire numbering and device tagging, automatic terminal strip drawings, and design rule checks. Really, there's just too much to really describe in a 22-minute presentation here. But the point here is that these features help the SolidWorks Electrical user focus on the development of their ideas rather than on the minutia of manually keeping track of vast amounts of engineering data. And since we don't have a whole lot of time to discuss all of these, let's move on to the topic of cabinet design. in project management. So before we do that, though, I would like to jump in here and give you guys a quick first poll question just to get a little feedback from you.
Thanks, Joe. And the first question is, what electrical design issue affects you the most? And please select one of the multiple choice questions above. Is it delays due to errors in CAD drawings, bill of materials, reports, time-consuming documents, auditing, checks, rework due to poor communication with the team, duplicate or missing items on the final BOM, or more than the above? And we only had 5 options, so none of the above is a no answer. So I just want to give everybody a few more seconds just to keep within our time frame, and then we'll show the results. All right, have the majority of people, so I'm going to close the poll and show the results. And more than one of the above is the highest. Other than that, time-consuming document audits. So, all right, back to you, Joe.
Yeah, very good. Thanks for the feedback, Cliff, and for everyone in the audience that responded. So now, when we talk about how we manage our projects and how we keep all this information together, we want to make it clear that the SolidWorks electrical project can include many different document types, and the collaborative engine ensures that every user is up to date. So users can organize their projects into multiple books to facilitate large-scale or modular project designs, and the project itself can manage all different types of documents, including synoptic diagrams showing the total system overview, specific wiring diagrams to give a higher level of detail, more detailed schematics, even more detail showing every wire connection. Then we can get automated drawings like terminal strip drawings. We can do quick panel layouts in 2D or 3D. And then, of course, we get a wide variety of reports. And all of these are available to us immediately as we start designing our projects. And what we'd like to do is talk a little bit about the content libraries here, because what we're also doing is we're tying together this shared environment with all these different types of documents with powerful shared libraries that all the electrical users can work from. And these libraries contain all the relevant part information, such as the manufacturer, the part number, and relevant specifications. And it also includes graphical links to all of the different representations of the components. And so by linking all of the symbols or the 3D parts directly into the component database, users can ensure that not only will their documentation conform to the company standards, but they can also ensure that they won't have to waste time either searching for or creating CAD symbols or models. It's all in the library, ready for immediate use. And these libraries can be further linked to ERP or other business systems so that designers can make more informed decisions earlier in the design process. And best of all, these libraries can be easily customized with the exact parts in custom data fields using simple import tools and setup wizards. Now, the process for designing a cabinet in SolidWorks Electrical is really a pretty simple process, because we already have all the information about the 2D footprints, the symbols for the panel layout, and we've already created the schematics, so we have all the information for what's in our assembly. So before I jump into this process, I would like to interrupt with just one more quick poll question.
All right, thanks again, Joe. Easier question. What is your primary tool for cabinet design today? You know, you pencil paper, use a lot of the office tools available, 2D CAD tools, dedicated electrical CAD software, or we don't do any cabinet design currently. So give everybody a few more seconds to answer the poll question, and I'll close it up. All right. I'll share the results, and 48% use 2D CAD tools, so followed by 20% dedicated electrical CAD software. Excellent. All right, back to you, Joe.
Okay, thanks a lot again for answering the question there. So what we'd like to do is just share some of the benefits of doing the electrical design and schematics. So a lot of you guys are using a generic or a general purpose 2D CAD system. And what that means basically is you're creating a lot of documents manually. Every symbol you look for is going to be, it's a uniquely placed item, and it has to be reconciled against other documents. And so what we're talking about with the way our system works is that there's a lot of advantages here. First of all, we're tying all the project documents together and synchronizing them. So your panel layout is actually linked to your schematics, and that's linked to your bill of materials reports. It's linked to everything. Everything's tied together here. Now, when we're putting together our system, the schematic tools are very easy and powerful to use. So we can draw schematics very quickly and efficiently, while the panel layout tools let us quickly just grab the symbols for any of the components we need to put on the rails and lock them right into place. We also include some automatic design rule checks and reporting that further reduce the possibility of errors. And these range from real-time detection of short circuits and to reports detailing any component terminals that may be unused. And as your projects grow in complexity, just know that we have the SQL-based architecture and the organizational tools necessary to allow many users to collaborate on large-scale projects. The process for doing cabinet design electrical is really pretty straightforward. We start off with our completed schematic for the project, and now as the user was drawing a schematic and choosing components, the system was automatically building the bill of materials based on the different component locations. And then the user simply needs to identify which location they would like to use for a layout, and then the cabinet, the rails, and the ducts, just placing them as simple 2D entities on the panel layout. And then you'll see a component list off to the side of the screen where we can click and just insert the symbols for any components that we want. So if I want to add a symbol for this fuse, I just right-click and say Insert. And then I can place it in all of my other components and quickly create my panel layout. Now, that's all well and good, and that's probably not so different than a process you might use today if you're using predetermined blocks for some of your components. But what we can offer with SolidWorks Electrical 3D is an even higher level of functionality here and a much greater level of realism, as you can see from this rendering here. If we take a look at some of the advantages of this, first of all, we can see visually that we have a much clearer picture of what's going on with this panel. We can even get a sense of how cables will be managed inside our different ducts. But the whole point of moving this to 3D, what's great about this is that we're expanding that pool of collaboration to include also the mechanical designers as well. This means that across all my electrical and mechanical design, I'm going to have a single bill of materials and a single set of product documentation, when the traditional process of keeping these design areas separate would require further document audits and hinder the flow of information from one team to the next. Now, secondly, when we get into 3D, as you saw from that rendering, we can do a lot with wires. In fact, we include powerful tools for managing the paths that your wires will follow, the segregation of how wires need to be separated from each other, and more. So there's a lot of capability in there. And on top of that, we'll create and manage manufacturing drawings like your panel layouts and harnesses, form board drawings for wire harnesses and so forth, and your terminal strip drawings. We mentioned calculated reports in the schematic or in the 2D panel layout, but when we go into 3D, we actually have access to more reports because now we know more information. We know the lengths of the cables, so we can give you power loss and voltage drop information. We know how many wires are in each physical diameter of each of those wires that comes out of the system. And finally, when it gets down to 3D, it's just easier for people to understand than technical 2D drawings. So it enhances communication. In addition, 3D users can perform simulations for damage impact. They can also take advantage of advanced visualization and rendering techniques, as you saw on the previous slide. If we want to take a look at what this process is in 3D, it really starts off pretty similar to the 2D layout that we showed earlier. First, we start off with our schematic. We choose our location just as we did before, only now we're picking 3D cabinets. We'll insert our rails and ducts as desired into our 3D cabinet model. We can start inserting components. Just right-click, just like we did with the 2D layout. Our 3D parts are available to us. We drag and drop them. They snap onto the rail. And if we want to take care of cable management, we can even add in some segregation rules. So let's just take an example, take a look at two different panels. Here's one that's run with no rules in place. As you can see, you see a red wire here. That's a high voltage wire coming down on this left side. We also have a blue signal wire coming in here to this lower horizontal duct. When we apply segregation rules telling it to keep the high power out of this left duct and telling it to keep the signal out of this horizontal duct here, we can immediately see how the system automatically solves for a better solution while taking our segregation rules into effect. And then finally, once we've done all that, we've not only built a realistic view of our panel, but we've also updated our project with important information such as all of our wire lengths and duct filling ratios. So we know a lot more from doing a 3D panel layout. And before we jump into the demonstration, which will conclude the presentation here, I'd like to ask one more poll question here.
Thanks, Joe. What would you benefit most from automation in your organization? So, and again, this is multiple choice. Give everybody a little bit of time to respond. Joe to get a drink of water. A lot of information there. And I see there's already a lot of questions already being asked, and Lou is answering a lot of those. But if you have further questions, feel free to answer them now. We're going to respond to a lot of these after the poll question and let everybody hear the questions and answers. So, all right, I'm going to close this up now and share the results. And collaborating across electrical and mechanical design is the highest at 39%, followed by creating manufacturing drawings at 30%.
Okay.
All right, Joe, back to you. Thanks.
That's great information, guys. Thanks for that feedback. And hopefully what we're showing here with this video demonstration is we'll be able to show you how we help bridge that gap in electromechanical design. So for this demonstration, what we'll do is I'll just walk you through a project in SolidWorks Electrical. The project is a 3-module stretch wrapping machine, and we opened it from a project manager. And we'll take a look at all the different documents in this project, starting with our cover page and the automatically generated drawing list. So this is really just a report from SolidWorks Electrical that automatically updates itself as you add more schematics. The synoptic view, as I mentioned earlier, gives us a great sense of the different modules for this machine and how they'll connect. So this is essentially a drawing from the SolidWorks CAD model, and it's been augmented with some location data. Next, we're looking at the wiring diagram, which offers a high-level view and shows how the different components are connected. Now, these wires are smart and they contain a lot of detail, so if I double-click on any cable or wire here, I can drill in to actually see the information of each conductor in that cable. And we can also drill into any component to access its information. So let's take a look at this relay here. You'll notice as we click on any circuit from the device down here at the bottom, you can actually see a preview appear to the right that shows its view, corresponding view of that symbol for that circuit on the multi-line schematic. And I did mention location several times earlier. What we're looking at here is a location outline that's defining all these motors as being outside of the cabinet. And this gives us a very simple way to organize our projects. We can organize reports and other documents based on location. You'll also see that as I drill in by location, I can access all the different symbols, which take me straight to the documents where those symbols reside inside the project. So just some great navigation tools from this linking to the search window that you're seeing up on the screen right now. All of this just helps you navigate complex projects in no time. Okay, so let's move on to the main power schematic for the project. And here you can see all of the power and protection circuits for our system. You'll also see these location outlines in use again to indicate that the motors this time are outside of the cabinet. And inside the schematic environment, as you see, there's a lot of different symbols here. We're looking at a drawing that's built using our IEC symbols palettes. But we offer a lot of different symbol palettes based on different standards. They're all organized very logically. We include really thousands of symbols to help designers get started with both electrical, electronic, pneumatic, and hydraulic devices are represented with our symbols. And then expanding on some of these time-saving features, you'll see these symbols have been organized to the left of the screen in convenient palettes for reuse. Now, this schematic does include an off-page reference from the output of this power supply. By clicking on the arrow, I can simply navigate to page 5, where we'll find the first page of our PLC documentation. SolidWorks Electrical includes comprehensive tools for managing and documenting large I/O devices like PLCs or high-density connectors. And on this drawing, we'll see more use of the location outlines for these external sensors, and we can also drill into the PLC component itself and see all the I/O for the entire device, not just what's on the screen right now. I did mention some, okay, we'll look at some more PLC drawings. You can see our different PLC inputs and outputs. There's the output drawing. There we go. And you can see, of course, all the managed devices, all the cross-reference tables there telling us where we'll find other references to those contact relays. And I did mention the automated documents earlier today. With SolidWorks Electrical, we can click a single button to get a detailed terminal strip wiring diagram like the ones you're seeing here. The system automatically builds the drawing based on your schematically defined connections and the style of drawing you choose. So another way that electrical solves time is with its integrated reporting. Now, the most productive users of the system will configure their templates so that they automatically include all the reports they need. That way, from the moment they begin a project, they're only one button click away from having all the reports generated that they'll need for any documentation or any project. Okay, and finally, we'll take a look at some of the cabinet layouts here. So let's close these up. And the first layout you see was created using our 2D layout tools that are included with SolidWorks Electrical. You can see the blue icons over on the side, and then that correspond to the components having the footprint. And then we've already moved on here to the layout that was created from 3D. And what's great with this 3D example is you can also see the hole tables that were generated automatically. Because when we place the switches and the cable gland knockouts on the panel in 3D, the system automatically drilled the holes for us. Those holes are now documented, so I can send this right to my shop for fabrication. So let's launch SolidWorks and take a look at this whole project inside the 3D environment. So once we're inside SolidWorks, we'll have access to all the latest project documents. So if we look over at the right-hand side of the screen, you'll see a viewer for the electrical project that's open right now. You can access any schematics, any terminal drawings, really any document I want from the project right away. Again, the same drawings we were just showing inside the schematic application. And so what we'll do now is we'll move our focus over to the left-hand side of the screen, where you can see that same componentry that you noticed inside the schematic package. So we see our locations, we can see all of our components, and this is where we can keep up with the components that are already in my model and the ones I still need to insert. But as we zoom into this cabinet, let's take a little closer look here and drill right in towards where the terminal strips are. And what you'll see in this is the level of detail that electrical offers. I mean, everything down to the individual core insulation colors on our power cables is documented here. We can also see the different thicknesses of the power and control wires, the paths that each conductor needs to follow. What we're really getting here is a very, very data-rich and visually accurate view of what our project is. We can also move out to other areas of the project that we're documenting, such as out on the conveyors where we can see our motors and sensors. And as we pan around towards the back of the project, we can see all the different components, and we'll also be able to see the back of this cabinet where we had all those holes for the cable glands. So you can see the cables, you can see how we've routed up through a power chain. There's really just a great deal of detail and rich information that comes through when we actually model everything here in 3D. We actually know everything we need to know about this project at this point. And the next step here, we'll take a look at this main electrical closet. We'll just isolate it, and we'll just show you how we get through and make the drawings of this. So you saw the 3D panel layout that was done earlier. And really, this is just a SolidWorks drawing. So we have our panel. You can see the inside of the door here. You can see rotate it around to get any view you want. And all we'll have to do now is just make a standard SolidWorks drawing of this assembly. So here we brought the drawing in with and included the hole tables as well, so we can see detailed information about where we're putting our routing clips, where we're putting our terminals, exact hole locations based on where we dropped the switches when we were doing our layout with the electrical components, and it's all very powerful. So what we'd like to do is just wrap up here. So today we covered how SolidWorks Electrical helps companies accelerate their time to market with very powerful, purpose-built, comprehensive project management tools, collaborative working environment, and a great deal of automation. And this is really just a part of a complete set of tools from SolidWorks that aid in the design of electromechanical systems. So we cover everything from now schematic design and systems planning all the way to final production. And along the way, we have opportunities for simulation, for doing 3D panel layouts, and even getting accurate manufacturing drawings, cable information, really the works. So it's a very complete system. We really thank you guys for joining us today. I apologize for running a minute or two over. And I think Cliff has a couple extra questions for you right before we go. Thanks.